requiring a rapid incrementation, the space race leads to the development of terrestrial technologies or space spin-offs, allowing us to amplify developments. Space has opened a new overall vision for emerging governments like never before, with different regions competing to reach our neighboring red planet. Innovations enter the field at revolutionizing speeds, as seen in the United Arab Emirates Space Agency's HOPE probe, the first ever probe to image Mars' whole atmosphere, completed in only 7 years, creating a new pathway for industries to believe in the idea of settling Mars by understanding its atmospheric composition and creating an everlasting hope in the upcoming generations. Hi, I'm Farah Youssef.
I'm Liane Raji.
And I'm Ahmad Al-Qawasmi.
We are BiogasX, a company dedicated to planning Mars' future, to showing the value of the commercialization of terraforming Mars as we use present-day emerging technology showcasing its value. We're the only company who showed methanation on Mars possible and more efficiently done than terrestrially. BiogasX discourages the overproduction of methane concentrations on Earth through gathering catalytic data about emerging technologies like carbon capture on a dry planet. Methane is 86 times more powerful than carbon dioxide as it nurtures the methylomorales oxifera bacteria. By gene editing its MC10 phylum, we increase its adaptation to the Martian environment. Nitric oxides have an average of 114 years, as they can also turn to nitrogen oxides in the stratosphere, damaging the ozone layer on Earth. Bacteria use these nitrites, and methane is a stable molecule, and degradation was believed to be impossible until an international team proved that it is possible without oxygen. Methane is produced 18 times more than the original input of hydrogen, and production rates for the plant exceeded 125 grams of liquid oxygen on a 6-hour production day. Thus, BiogasX took advantage of this and came up with our terraforming solution, Toronto 5. We simulated their growth in anoxic environments through continuously sparging it with a gas with a mixture of methane and carbon dioxide, 95:5 volume ratio. Mars has a concentration of CO2 to O2 of 95%, and in the Toronto 5 process, we used a nickel catalyst for results and located our plant on the Gale crater due to its relatively high concentration of methane.
Previous companies have attempted to terraform Mars using different methods, like SpaceX's infamous nuking Mars plan. Elon Musk has previously planned to terraform Mars before receiving lots of backlash due to his unrealistic plans, lacking possibility and also consideration of the debris onto Mars' atmosphere, affecting the planetary defense. The major flaw of this plan is the lack of resources. Through Toronto 5, our adiabatic reactor's bed's distinguished design will be taking place without transfer of heat or matter between a thermodynamic system and its surrounding, hence making it better than the existing reactors. To increase the methane, our bioreactor has 5 of these beds with intercoolers and low temperatures. There are RTGs. However, they only generate tons of watts and aren't suitable enough for powering Martian factories. With the addition of geothermal on Mars, generating a 20,000 times higher energy flow, and Martian temperatures are more suitable for shallow drilling. Exposing carbon dioxide that are stored in ice caps, geothermal energy increases terraforming rates on the Gale crater.
The Toronto 5 process occurs during the Martian night, where a sorption pump pressurizes carbon dioxide and adds heat through selective absorption. Our hydrogen recovery pump is used to increase the efficiency of composite solid polymer electrolytes using propylene carbonate as the host matrix and silica nanoparticles as the filler. Here we account for several values for compatibility to range with electrodes. Processing occurs in the solid state angle spinning, nuclear magnetic resonance, and X-ray photoelectron spectroscopy. Studies to identify and release them into the atmosphere. Heat is fed into the absorption compressor where oxygen products are dried and scrubbed off residual CO2 for liquefaction. We use a Stirling cycle cryocooler under closed loop control to lower gases by maintaining ambient temperatures and dewater pressure in production hold periods. Closed loop controls provide simple, reliable, state-ready production. Oxygen is produced for CH4 conversion to methanol by methane monooxygenase using nitric oxygen dismutase, producing nitrogen and oxygen adiabatic beds at plug flow blocks. Condensation of the first and second adiabatic bed at 80 degrees Celsius, 17 bar pressure, enrichment and extraction of MC10 phylum running at ambient pressure for inoculation, and a 16-liter glass bioreactor isotopically operates at 3 to 7 days, settling from 1 to 2 hours and 36 to 60 minutes to do liquid from megalith.
Additionally, some of our expeditiously researched power systems will include 24,100 kilograms of battery charge-discharge units. They can provide up to 6.6 kilowatts to the plant. Each day, the BCDUs should undergo 16 charge or discharge cycles. Also, our lithium-ion batteries will be designed for 65,000 cycles and 10 years of lifetime. In the process, electric power is obtained by using solar energy, moving the turbines by the steam to the thermoelectric power plants. Moreover, the thermovector receives solar energy transformed into thermal energy released in the water, activating the turbines of the power plant, producing electric energy.
Diverse proposed methods for terraforming Mars have been proved inefficient or not enough, such as importing ammonia or using orbital mirrors. Jim Green from NASA suggests that using a magnetic shield could significantly reduce the solar wind, establishing a new atmosphere, protecting the planet from high-energy solar particles. The problem here is that the idea is here, but the technology is not available. Moreover, another company, some beta factories technology, mimics photosynthesis, creating useful chemicals from sunlight. One of its negativities is that the red planet has a lot of infamous dust storms, which could reduce the effectiveness of the technologies, since they rely on solar power. Here at BiogasX, our idea differs from their ideas, mostly due to the fact that our idea is quite unique, efficient, already measurable with present-day technology, and ready to be done. The concept itself is guaranteed to be effective, and everything is set and complete. Terraforming Mars is now possible thanks to our new and advanced idea.
Our market segments in the space industry include ground production and manufacturing. Its market size has risen to over 11 billion USD in the past years, and we are entering various sectors in the space industry such as the satellite network, construction and supply chain. BiogasX will have an annual growth rate of 8%, where excess gases of methane and CO2 will be recollected for rocket fuel and sold. We utilize a percentage of our nitrate products to sell them to suppliers on Mars for future plant growth operations, entering our product in a market where costs are consistently reducing and an opportunity to launch our business. Rockets cause a reduction from prices of 200 million USD to 60 million USD, with studies saying that they could reach up to 5 million USD in the future. Governments, and we also utilize a ratio of 60 to 40, government to other commercial services ratio, and one of our unique value propositions is transferring data on methane to the local community, spreading awareness through partnerships and services, all on a web-based platform live. We rely on subcontractors for creating vacuum strong enough to simulate Earth's pressure on the planet. Our business model uses three ratios dictating our market value and penetration. Price to sales ratio, which is the bulk that the company earns money through, the price to earnings ratio, and the equitable flow of materials such as to sustain such harsh environments for the long term and reduce fixed costs. Through branding, we publicize engineering with environmental consciousness on Earth and Mars. We consider the production costs to be less than the construction costs as they were for the Rocket Lab's Electron rocket. To maximize development independence from subcontractors, satellite developments are done in-house with telecommunications with partnerships. Costs include the replacement of catalysts, the cooling media, and the handling of the necessary water and maintaining gases and sequestration. Three economic factors which we continue to include for our operation strategy are the market price of and the willingness to pay/accept for the SNG, CO2, and electricity.
The future holds exciting and creative advanced discoveries in space exploration. It takes hundreds of companies to create and maintain our physical infrastructure here on Earth. So too will it take as many ideas and as many voices to build that on Mars, to support exploration and habitation. The future also holds people, youth, and general science communication that inevitably ties the value of BiogasX, where we will plant Mars's future.